Hello, hello. It's Friday, 4 p.m. here in Berlin. My name is Jurassi Pashankroning. I'm a software engineer and I'm with the Open Telemetry project for a few years now, since the Open Telemetry project was started in 2019. And this is Telemetry Drops, a project, a personal project by me, Jurassi, where I bring to you once every couple of weeks something about Open Telemetry, perhaps sometimes about observability, monitoring, or telemetry in general every couple of weeks because I alternate between Telemetry Drops and Dose de Telemetria. Telemetry Drops is a spin-off of Dose de Telemetria. Dose is in Portuguese, so if you do speak Portuguese and English, you have content every week here. Dose de Telemetria exists for 3 years now, a little bit over 3 years, and Telemetry Drops, we are here for a couple of months only. And I'm very happy that we are doing Telemetry Drops, and because I have the opportunity also to talk to some of the people building the technology in building open telemetry as well. This is the case today. In a couple of minutes, I'm going to call here my special guest, one of my favorite people in the open telemetry community. But perhaps a few words here. So we have a KubeCon happening in a couple of weeks' time. If you are at KubeCon, ping me, let me know. I'll be there. I have a couple of talks prepared, but I'm also going to be there talking about open telemetry, observability in general. So if you want to chat about that, ping me, wherever you can find me. I'm on the CNCF Slack. I'm on LinkedIn. You can find my email as well quite easily. Beyond KubeCon North America, which is happening in a couple of weeks' time, we also have the CFP open for the Observability Day in Europe next year. So that is happening in March. So the CFP for KubeCon is not open, so it's closed already. We are right now looking at the abstracts and judging the talks there. But the CFP for Observability Day, I think it closes actually this weekend, or did it just close? I don't know. But it should be open still for a few more days. If you haven't sent your proposal, do send it. We need more people to send their proposals. We need, especially if you're an end user. If you are an end user and if you have a unique story to tell, prepare your story and share that with the community. If you need some help in looking at your proposal, let me know. I can certainly find somebody to help you review, to do a pair programming session with you on your proposal. What would be the right term for that? Anyway, so that's on conferences. We also have Hotel Unplugged. Hotel Unplugged happening in February next year, right after FOSDEM. So FOSDEM happens on a weekend. I think it is at the very beginning of February. And on the Monday after FOSDEM, we have Hotel Unplugged. So if you are planning on going to FOSDEM, or if you are close to Brussels, then do think about attending Hotel Unplugged. It's an unconference type of conference where you can hear from people from the Open Telemetry community and from users, and you can also propose your talks there on the spot. Hotel Unplugged is I was at the original event back then in Detroit. That was a great event. I had so much fun there. I got to know a lot of people from the community as well. So if you have the chance, if you have the opportunity to join Hotel Unplugged, do so. And this week or next week, we also have the Hotel Governance Committee elections. If you have more than 20 contributions to Open Telemetry for the past year, then you are eligible. Contributions here is GitHub contributions. You are eligible to voting. And if you have contributions to Open Telemetry which are not on GitHub, so if you've helped writing blog posts or doing conference talks, or as helping users on Slack, or any contributions really count, then apply for an exception. You have the right to vote as well. But hurry up, I think it is only for today. So by the end of today, the form closes. So go there and make sure that your voice is heard. And I think that's what I had. So Carla always asks me to tell you to click the subscribe button if you are on YouTube, if you are on LinkedIn, follow the page, and so on and so forth. Apparently that helps the algorithms to spread the content to people with the same interest as you. I don't know, just do it. And I think The other thing is take a look at telemetrydrops.com. So we closed the presential workshop here in Berlin, 28th, 29th. So this is not open anymore, but we are planning the next one for January next year. All right. So if you are interested in a in-person 2 days workshop focused on open telemetry collector. So you're going to learn how to build components for the collector. You're going to learn how to manage collectors at scale in production. Then go to telemetrydrops.com, sign up for the waitlist. The next one, I think it is January, mid-January. So if you are interested, go there. That said, I'm very happy that perhaps a little bit of background here. We have a Telegram channel for Dose de Telemetria in Portuguese, and somebody there asked me, "Oh, are you planning on having a isolation forest processor lesson for Dose de Telemetria on the course, dosedetelemetria.com?" And I said, okay, I know nothing about that component, but I know somebody who knows. And I'm going to invite that person to come here and talk to you about the isolation forest. So that's the idea for today. We're going to talk about the isolation forest processor. I still don't know anything about it, but that's about to change. And I'm calling now here Antoine. Antoine, hey, welcome to Toronto.
Thank you for having me. Thank you
Yeah.
for the intro. Great to be here. So, wow. Maybe I should introduce myself a bit. Is that a
Yeah.
good idea?
Yes.
So, I've been at Splunk for about 5 years. And I've been working with OpenTelemetry since about 2020 or so. Just to retrace my steps a little bit, because it will explain a little bit why I got myself into that processor. My first interaction with the project was with Contrib, the collector Contrib project. One of the things that were missing for Splunk support was to have a good exporter for HEC, the HTTP event collector. And I was looking back, some time ago, we had the cards come out where you could see your first commit, right? And first commit apparently was that HEC thing. We just went straight for the really hardest possible things to drop a new component into the distro. Looking back, it had like something like 66 comments. It took 3 months. It was pretty difficult. And in general, like this is kind of really fashioned my journey with OpenTelemetry. I found it was very difficult to drop new code into the collector. And we do have a lot of things in Contrib, right, in the collector Contrib repository. So what I started to do was maybe a bit odd at the time, but instead of trying to go and do a really good job with code and better performance or better contributions, what I found is, given my past of being involved in the Apache Software Foundation, Eclipse Software Foundation, I thought that the main thing that we should pay attention to is how do we get more people to help? And how do we get more and more contributions from people from the outside? So I did some really silly things, like if you go at the README at the top, there's a little thing that says how many bugs you have open, things like that, right? Well, I was pretty proud of putting this little thing together because people were able to just eyeball right away. It's like, here, how many issues you have on this component, right? And it started to boost a little bit the confidence and also put more forward the code owners of a particular folder. And so I started to kind of climb the ranks from being just a casual contributor to a triager to an approver. And as of March of this year, I became a maintainer on Contrib, right? So, and to me, that's been more of this type of work is doing, how do you manage at scale this level of project? You have to have linting in place. You have to have all sorts of checks. How do you reduce the amount of toil that code owners have to deal with? And how do I make it so that I can add more components without sacrificing the stability of the whole repository? So I'm kind of the person that people go to every time there's a new component, which is great, but also not that great. And if you were to look at the isolation forest processor right now, I'm the only code owner, which is not what I wanted. So the way it works is when you want to have a new component, you open an issue, you find yourself a sponsor, who was me, and then you eventually become a member of OpenTelemetry, and then you get added as an additional code owner of the component. But the sponsor is going to be the first code owner for all intents and purposes, so that if anyone wants to yell at somebody, they can find them, right? So being a sponsor actually has a lot of cost. And this is why I'm on this podcast today is because I ended up knowing way too much about this. So now let's talk about maybe the processor itself, if you want, right? Let's get into the meat of this. So why does it even exist? Who came up with this idea? Where is it there, right? So on the CNCF Slack, you can find those discussions. One person named Shiva RV, who is really good at his job, came up one day and said that he works at NPCI. NPCI is apparently dealing with instant transfers of money in India to the tune of 700 million transactions a day. So this person has a very different set of problems than most companies that you would have in the wild, where you have maybe 10,000, 20, maybe a million transactions a day. We're talking about something that cannot be actually stored anywhere, right? And I think we're just scratching the top of that iceberg too. Like he's just having to deal with so much complexity. So this person is not interested in storing everything because that would be madness. But how do you get some signal from the noise, right, in that type of situation? So he came up with this idea of applying some level of sampling, or at least some idea of identifying some interesting data from the noise by using this machine learning algorithm called the isolation forest algorithm. He's not interested in keeping everything. He just wants to keep anything that is an outlier, that is weird, that is out of the norm. Interestingly, that processor applies to any signal and can be applied to any attribute on any of those signals. So, and I think it's coming from the fact that it's also something that is used a lot in financial services for other use cases. That's when I started to look a bit into it for this podcast. I found out that it's actually used in fraud detection more than anything else. It's great for credit card transactions, for example, when you want to understand if someone is making maybe a payment that is higher than normal, or they're making a payment at a time of day where they don't usually are supposed to be awake, or they're making a payment in the location that's far from where they usually make their existing payments. So that's the point. It's like, first off, we are trying to find data that is out of the norm, that is kind of out there, does not match anything else before, and is going to use some historical data as basis, right? So for that reason, we call them a Wikipedia page you can find, right? So we'll call it a unsupervised machine learning algorithm, meaning there's no human in the middle who's telling us how to classify the data. We'll just go and get all that data, get it into the machine, and it will start to spew out anomalies. So how does it work is very interesting, because first, it's a very efficient algorithm. It's an algorithm that does not require as much memory as others, and can be done on a floating window basis. So you can have, so the way it works is that you're going to take a space of points, right? For example, the durations of your spans is kind of an easy one to look at. And you're going to have this axis of all the durations. You're going to start to divide by 2 that axis, right? And then you're going to start to build a tree from that, right? A binary tree of sorts. And the outliers will start to pop up as the element of the tree that has the shortest path, because the bigger set of points, let's say in the middle of your view, will always have the deepest leaves inside your tree, right? And so you can train some data. You can do this for 100 times first, try it out. Then you take a test point and say, where is that test point going to be landing? So you compare it to the existing tree and you go, is this deep? Is this going deeper? Is this going deeper? All right, I think that point does not need to be considered as an outlier. But is it shorter than anything else in that tree? Yeah, it looks like we have an outlier right here. Is it longer? And then therefore on this other side, and we can do that. So once you have this tree, you use it as an algorithm itself to run it against existing data. And then you can replenish the tree in real time with existing data as well. So your window of time will change. So that's actually an interesting point, is that when the first contribution of this processor was made, it was great, I guess, but we made it market development. We wanted to get some feedback from people. And then came along another person who I don't think we had any correlation whatsoever, and I said, well, I think I can do better, right? And they started to work on this, added more tests, and they added this adaptive window this time. And the name of that GitHub users, a big shout out to them, is Venu Emadi, who just decided to put it on themselves. Like, I think this is not good enough. I can do more. So this is also like this power of open source, where it's just now in the wild, and you can make it better, right? You can come in and make it better. So there's a couple things that they do, right? It's just like probabilistic sampling. You can have it drop the data that is outliers, because maybe it's not what you want. Like, it's too out there and it doesn't make sense. But the other thing you can do is you can add an attribute to say this is anomalous on any span, metric, or log.
I have a question. I don't know if you are open for questions already, but I do have a question. And for anyone watching, if you have questions, use the chat here, either on LinkedIn or on Telegram or on YouTube. The question that I have is do I have to specify where to look for data, where to look for anomalies? Do I have to specify I'm interested in durations, and then it builds a tree based on durations, or do I have to, or can I just say, well, find anomalies on the span attributes, whatever it is? It might be on span name, it might be on a specific span attribute. Like, how does it work in terms of configuration?
Yeah, right now you can specify it on any signal. I don't think profiles are supported, which, yeah, that makes sense. That would be a bit early. But for logs, traces, and metrics, you can specify. So, for example, for metrics, we have an example in the README that is using the value of the metric, but you could use any attribute of the metric. For spans, the example is using duration, but you could use any attribute of spans. I would be interested in having even, like, I think we're just scratching the surface, because you could have maybe a combination of those things, for example, right? That could play out, and so this is what you can do at this time. The example is using the severity of the logs to do the anomaly detection, which is kind of interesting. If you think about it, right? If you're inundated by logs, you might like to see any log that is kind of out there. If you go by body, it might be too much. But if you go by severity, you could just start to catch any weird errors that are popping up. Like, you can do all sorts of interesting things like that.
I mean, we have only a few severities available, right? So the bug, error, and warn, and so on and so forth. Like, do you tie that to a specific, like, how do you find the anomaly there? Is it about the frequency of a specific severity of the log, or what is the anomaly there?
And it goes back to the what I was saying, is like, it should be not just for an attribute, multiple. I think it might be possible to do multiple. I don't know.
Okay.
I need to try. But the way it works is that if you have 99% of your logs being debugged, for example, and 1% of your logs being errors, then all your errors are going to go into a separate part of the tree right away, and then they'll be detected as anomalies. That's another thing to note is you can fine tune a little bit how much you want to detect things as anomalies. So you can say maybe 5%, 10%. You have a ratio between 0 and 1 on how much you want to be tracking things, so that you can have you can be a bit more circumspect about what you're going to report, or you can go and really push everything in there. So it allows you to have a bit of measurement around what you're doing. And by the way, it's not going to be like 100%. What we're trying here is that we're in a very imperfect situation at this point, right? We already know we can't read all that data, and that's the really interesting part of all this, is that no backend. Like, this is going to stay inside your collector on the fly as you stream all that data. And I think it's a bit of a new trend that we're seeing in observability for this type of components. Like, the same person came back and gave us another contributions after, and it has the same kind of feeling. Is like, we have so much data that it will never make it to a backend. And we're dealing with a very imperfect situation where we have to start to pick our battles, right?
Yeah.
So, yeah. So, yeah. Any other questions?
No, yeah. Perhaps one comment that I have is like, there's a lot of bad telemetry out there. Like when I heard that for the first time from Dan Blanco, that just I just had it for like with me since then. I have it even printed on a T-shirt here. That's
Yeah.
the title of our talk at KubeCon as well. Because, and I think one of the things that you are saying there is, I have my hairs on fire right now because I have so much data and I have to deal with that right now. So I have to,
Mhm.
on a easy way, I need to find out what matters the most right now, and then I can look at that data. Um, Perhaps the long-term solution is to clean up that data at some point, but having the collector in the middle and being able to filter that data there, I think it is important. Eventually, I think we're going to get into a situation that Vijay mentioned during, I think it was in Salt Lake City during his talk there, perhaps Observability Day, where he was explaining something that I call the VJ sampling strategy, which is he ingests everything. Of course, not everything at eBay scale. It's not everything. It's like I don't know, 2% or of whatever they do, which is already like a lot. It's huge, and they cannot do tail sampling, for instance, in the hot path, in the critical path, because that's a lot. Like they cannot operate. So what they do is they dual ingest, and then out of band they do a sampling of the data. So they store in two places. One is hot for 7 days, and the other one is sampled for 30 days or so, or for longer term. So they have two data stores for telemetry data. If there's an incident, I go to the hot one for the last 7 days, and I have 100%. Otherwise, I go to the
Yeah, that makes sense.
hot. But and I guess what I'm going with this comment is that something that people would do on the critical path, like on at the hot path, or do you think that we would? One thing that I'm seeing a lot is people ingest data with one collector. The collector puts in a Kafka stream somewhere, a Kafka place somewhere, and then from there it spreads out. Is
Yeah.
that from the isolation forest? Does that go to the backend later on, or is that something that feeds back into a collector saying, you know what, this is what should be done?
I Yes, I think this is so. Two things, right? First, I agree. I think it should be on a critical path. In Could be done because there's a couple nice features about this that it can be done in parallel to your normal processing, but still on the critical path because it's fairly fast. Um, by the way, the processor has an interesting feature. I think Shiva this is where you see a little bit of the genius here, is that it's got some memory limiters associated with the tree itself. So you already have some notion of keeping yourself somewhat accountable to a certain memory consumption. So even though you might be, pushing really, really hard a lot of data through, it's not going to overflow your whole memory and take over the whole collector. It could be its own deployment on its own, right? Of course. Why am I saying it should be on the critical path? I believe that I've had some interesting discussions with customers who at large have the problem where they want to detect outliers. It's becoming more and more interesting, and this is what people really want. They don't care about the main path of all the data. You're no longer in the investigation mode of something happened at that time. I want to see the whole Gantt chart of my trace, and I want to understand that. What I'd like to start to do is proactive observability. I'd like to start to see the weird and unknown. Why is that person doing this? Why is that one span doing 30 seconds instead of 5? I've had that discussion where someone's like, 99% of my traces are perfect. I don't care. But there's this 1% of those things that start to really behave in that really weird way. And I'm getting absolutely like hammered about this because they're not failures. Those spans are not considered errors. We don't really know how to watch for them. How do we start to get better at this? How do we have some intelligence in the pipe so we can start to get better at understanding those use cases and be proactive about them? So I think there is value there because you still want to get this data as soon as possible to your backend, and it might actually be actionable compared to some of the things of just getting everything in one big bucket. To your second point, you mentioned something interesting. I know you're really like the instrumentation score project, and I really like being able to contribute with that a little bit. I think there's some level of instrumentation scores that could play into this, where you could apply some of the recipes and say, this data is anomalous, and I'm going to track it. But you can also treat it as, I really think this data is garbage. Can we drop this now, right? So this is not foolproof, but there's a bit of that thinking that goes into this. And yeah, it's cheaper than having to do it at scale when you're going to apply all the rules for all the things. So maybe you can just pick one rule from the instrumentation score project and apply it here, and find that your data becomes 10% cleaner, and then you can have better averages or latencies, and you can start to have better analytics based on your spans, and your metrics make more sense, because there's just stuff sometimes that doesn't need to make it to a backend because it's just not good, right? So
Yeah. Yeah. I mean, one thing that I saw this week was the second most frequent log line from a company was message received successfully, like that string of text. That can be a metric, right? That can be a metric, or that can be dropped altogether. Like, do I need that information? And that's the second most frequent log line for that specific user. Like, again, there's a lot of bad telemetry out there, but I think so. There is a question from Claudia here. Could we tackle the metric cardinality with that? Can we use that to detect high cardinality? What are
yeah,
the
it doesn't really apply to cardinality that much, because so let's say you have an attribute that is exploding constantly, right? So you get high cardinality of this. The processor could take this attribute. Let's say, what would be a good attribute for this? It could be host.name, or it could be the IP.
user ID?
User ID.
Somebody's storing user ID.
Everybody's running as root on your box, and all the metrics have this user root on them until it's Bob. And then you need to know that Bob did something, because we really think Bob should not be logged in at 5 p.m. on that Friday downloading these files or whatnot, right? So what the processor does, again, is like, it's going to find things which are anomalous. And it's just statistical distribution of like that data, right? So we're just creating the tree, going down, everything is root except this with odd value on the side. Okay, that is the cardinality that I want, is not get 100% of everything, but that one. Even if you have a high cardinality, let's say you have 10,000 users, maybe Bob shows up once. Maybe that's valuable data. Maybe you want this. So you could just grab the values that are on the extreme of your axis. Like, you see this only never or all the time, and those two things are really disjointed. So you would be able to identify not the main brunt of your users, but the people who have weird outlier type behaviors.
Got
So
it. Yep. So basically, I'll get the trace where the user is Bob. I would see on my backend, but I wouldn't see all of the root users
that's
that were okay. Yeah. Now, that reminded me of a few discussions we had on the sampling side of the house. One of the things that people, when we talk about sampling, sampling is basically discarding data. Like, I pick what I need to save or what I want to save. And one of the problems by doing that is when you discard good data, you don't have a base to compare the bad data with. Like, what is my error rate? I don't know. I don't have the successful ones, so I cannot calculate an error rate. Right? Of course, if you know what you need, you can pre-calculate the metrics beforehand. But that kind of defeats the purpose of observability as a discipline. Like, we need to be able to ask questions and get answers. Like, this is the classic observability story. How do we? I mean, I guess when we start using isolation forest processor, we kind of give up on that story, right?
it's the same problem, right? We decide that we can't observe everything because we are just overwhelmed with how much data is coming in, and we're going to have to make some tough choices. So we're going to want to specialize in having signal that is highly valuable come first, and maybe we can progress from there, but we're just having to deal with an imperfect situation. And this is really coming from that use case, from that particular user, right? Having 700 million transactions a day. The way he presented it initially in his contribution was, we have more transactions a day than Visa. I believe it, right?
Of course, I believe it as well.
And I think they're just giving up on everything that they've been. Traditional observability just doesn't work anymore. I'll give you just a teaser. It's like the next contribution that same person made, Shiva, was an alert generator. So he's saying, we don't have time for backend. We're going to apply some rules, and we're going to generate alerts right here and now inside our pipeline based on policies that we're going to be defining as part of a collector. No backend, no more, no need. Let's go. Let's actually start to directly interact with the signal as it comes in. Get people on site working on the issue. We don't have time to store the data. We need to. It doesn't matter, because by the time you're reacting to the alert, you already have 10 million more transactions that come in. So it's really not for everybody, right? It's a really risky approach to things, but it's also very interesting to see this transition from being able to classically store and reflect on data to having to deal with this streaming approach of all the alerts and all the updates that you want to make.
Okay, now tough question then. How do I scale that? Like, it's not a stateless algorithm. Like it stores data on a sliding window, if I understood correctly.
Yes.
And you cannot just have every collector with its own sliding window, or perhaps can you? Because I guess eventually you're going to find the same patterns across all of the collectors, right?
It's not cheap, right? You're going to store data. And so the way the isolation forest processor does it is putting a memory limiter, which is actually, I would welcome more review on that, which is storing data on the fly from the data that is coming in as a training set, and then applies it to the test set. So the good thing is that you can actually define the size of your training set, and you're going to define the size of your training set. It's going to define the quality of your sampling or anomaly detection, right? So if you look at the configuration of the processor, you can define the depth of your tree, and you can define how much memory you want to keep on that tree. By default, we keep about 500 megabytes, which is nothing, like compared to some of the examples we have seen over the years. And so I think it's the other thing is, there's no, like, probabilistic sampling has this approach where you're using the same seed hash for everything. But in the case of the isolation forest processor, you're just not going to see the same data. There is no way for you to make an educated guess if you're going to get the same response between two collectors, because they've been fed different training data. They might make a different decision about the next span they see. Right, and unfortunately, that means it's not actually completely probabilistic. Like you can't say this span will be tagged this way.
So do you send different workloads to different collectors, so they're not part of the same cluster?
You will want to partition your data coming in, I think,
Right.
so that you have a better chance of detecting anomalies, which are, like, for example, you would do it by service, so that you have anomaly detection under that service, right? So there's some level of partitioning that you can apply here for sure. What else was there? So in terms of scaling, the other thing this thing does is that by default, it just tags the data by adding an attribute that says whether it's anomalous or not. And it doesn't do much, but you can make it drop data so that you can scale in terms of and sending data that only is anomalous or vice versa. By default, looks like what the processor has a bit of an opinion right now, where it can allow you to drop anomalous data, but does not have the other option, which is only keep the anomalous data, which to me is more interesting, but I don't know. So yeah, I think it scales fairly well. The algorithm is known to execute linearly, which is quite unheard of when it comes to this type of things. I would say, so interestingly, right? So when we talked about this earlier, I said it applies to different signals. It applies to spans, metrics, and logs. But you probably noticed I did not mention that it applies to traces. Because what would be really nice is you get the whole trace, and then you can make some call on that.
Yeah.
Keep,
So that's where I was going after, just after your comment, that it does make sense that we don't need to scale that we don't need to keep a state between collectors because we are judging on a span by span basis, right, on this isolation force. Whereas in the tail sampling processor, for instance, we keep the whole trace in memory because we are making a decision for the whole trace. So we have to have another layer of collectors before that doing the trace ID based load balancing so that all of the spans for the same trace get to the same collector. Now, you don't need that with the isolation force processor because there's no state to be kept. I mean, each collector would have its own state. You can shard data, of course, the way that you mentioned. We can have like half of the service name payments go here and half of the other ones go there. So you can split data. You can chart the load without too many. I mean, of course, you're going to end up with repeated data in some collectors, but I think it's fine. And as you said, I mean, they might not get to the same conclusion at the same time, but I think that's fine as well. Blake had a good question. The question is, can we tell this processor to keep some percentage of the baseline, not the outlier, data to pass further into our pipelines? I think the answer is connectors, right?
Yeah, I was going to say that. This is probably a forward connector. You would just fork the flow in your trace pipeline, where you would have the same receiver go to two different pipelines, trace pipelines, one that goes through the isolation first, and we manipulate the data however you want. And then the others, we go to your good old tail sampling or probabilistic sampler, and then we apply the same approach here. And then this way you can compare a little bit. I think, so to be clear, I would not be given the level of maturity of this processor, given also all the discussion we just had, like it's really good for anomaly detection, thing like this, I would not stop ingesting traces and just trust this thing. What I would do is make it a parallel thing as an experiment, try it with my team and say, do I actually see anomalies coming in? What type of tuning are we looking for? What is the attribute? Because we talked about that. Like there's a lot of interesting attributes you can tie yourself up to. There's duration is one that's kind of obvious, but maybe there's something else that we would like to understand better. And try that on the side as a separate ingest and see what data you get that makes you think twice. Like, this is super interesting, and I did not know that. Like this aha moment, right? Or worse, just also get a sense of like, are people paying attention to this? So going back to the instrumentation score idea, just throw some instrumentation score type thinking around this and apply it and go back to customers and to your operators, users, application developers, and tell them they are not passing the isolation forest. There's ways to do it.
Yeah. I so many things. I mean, I could stay here for the whole afternoon talking about that. Antoine, anything else that is not isolation forest that you want to talk?
I am super happy to see you at KubeCon. I will be there. This can be a big party. Hopefully, we'll have a good time. The observatory is open again. You did a really good job of plugging all the events for the next quarter, so I hope I'll see you at all of those. But yeah, so if you're a member of a SIG or if you're interested in OpenTelemetry, we have a form that we shared on Slack. If you would like to push a particular session, have some time to discuss about particular topics, this is a great way to kind of get some time with us, and we can put it on the whiteboard. Usually, it's more like on conference style type meeting place. And this way you can get some time with everybody from OpenTelemetry.
That's very cool. Antoine, thank you very much for accepting the call, for coming here and telling us more about the isolation forest processor. I'm looking forward to seeing you in a couple of weeks in Atlanta. It's Atlanta, right? Yeah.
It is.
And thank you very much. And for everyone else, I see you in a couple of weeks' time again here at Telemetry Drops.